Have you ever been puzzled by unexpected behavior in your code? It can be frustrating, especially when you encounter something as strange as rounding a NaN value in Haskell. If that sounds familiar, you're in the right place. Today, we're diving into this curious case and uncovering the mystery behind it. I totally get it. Finding out that rounding NaN returns a gigantic negative number can leave anyone scratching their head. You're not alone in this confusion. Many developers have faced similar surprises while coding. Let's take a closer look at the specific question at hand. One user recently discovered that when they tried to round the result of 0 divided by 0 in Haskell, they received an enormous negative number. They also noticed that the same behavior occurred with the floor and ceiling functions. Sound familiar? Let's explore this together. So what exactly is happening here? In Haskell, NaN stands for not a number, and it represents an undefined or unrepresentable value. When you try to round NaN, the result can be unexpected, leading to those gigantic negative numbers. Let's break this down further. And stick around. By the end of this video, I'll share some alternative functions that handle NaN more gracefully, which you won't want to miss. To understand the behavior of rounding NaN in Haskell, the user should first recognize that NaN stands for not a number. It represents an undefined or unrepresentable value, particularly in floating point calculations. When the user attempts to round NaN using functions like round, floor, or ceiling, Haskell returns a large negative number. This is due to how floating point arithmetic is implemented in Haskell, which can lead to unexpected results. To handle NaN values more gracefully, the user can create a custom function that checks for NaN before performing rounding. This function can return a more sensible value, such as 0 or a specific error message. Additionally, the user can explore existing libraries that provide safer alternatives for handling NaN values. Libraries like data.maybe can help manage optional values more effectively. In summary, while the behavior of rounding NaN in Haskell may seem surprising, understanding its nature and implementing custom solutions can help the user manage these cases more effectively. Fun fact, did you know that NaN is not just a programming concept? It's also a term used in mathematics to describe undefined values. So next time you encounter NaN, remember, it's a universal concept. Now let's look at the answers provided by other users. One user points out that the issue of rounding NaN in Haskell has been recognized for some time. They reference several tickets filed against GHC that discuss this problem. They believe it is a genuine bug that should be addressed by throwing an error instead of returning a large negative number. The user explains that this issue is complex, involving trade-offs between speed and correctness. They note that the Haskell report lacks clarity on this matter, leading GHC to prioritize performance over proper error handling. Here's a quick tip. Always check for NaN before performing operations that could lead to unexpected results. This simple habit can save you a lot of headaches down the line. And there you have it. Now you understand why rounding NaN in Haskell returns such a bizarre result. Remember, checking for NaN can help you avoid these surprises. If you found this video helpful, don't forget to subscribe for more insights and tips on coding.